Am I audible, sir?
Yeah, you can start.
Okay. Good evening, everyone. I am Dr. Abrar Khalak, and today we are going to learn something very practical and interesting. This session is not just a theory. Today we will understand how real world roads are converted into actual design. Simple words, the roads you see on a Google Earth, how we bring them into Civil 3D and work on them. That's what we will learn today. So don't worry if you are a beginner. We will start from zero and build a strong and basic foundation today. So here I share my presentation first of all. Uh, so here this is me, Abrar Khalak. I am a transportation engineer. I completed my bachelor degree in civil engineering, master degree in transportation engineering, as well PhD also in transportation engineering. I'm a civil 3D based road and infrastructure designer. Today, this webinar is in association with Castillo Design, which is located in Mumbai. So Castillo is one of a good frame in Maharashtra, India, who is doing all type of infrastructure design work, which is based on even it is on a civil 3D, AutoCAD, GIS, or whatever the tools required to do. So before we start, let's quickly look at the tools we will use. We will be using four main tools: Google Earth, Global Mapper, Excel, which is we use as a basic, and Civil 3D. Now let's understand their role in a simple way. First of all, Google Earth. So we use Google Earth to see the real world locations. Then Global Mapper to process and improve terrain data. Then Excel for a small calculation, file creation, and a little support. And the last one, Civil 3D, to create and analyze the design. So basically, three steps are there: real world, data, and design. So this is the complete flow we will follow today. So here, for today's class, I prepare this image. Now you see here in a today's workflow overview, you can see 7 type of different diagram in one slide. The first one is start with the Google Earth view, then terrain extraction, then global mapper DEM, civil 3D surface, geolocation check, and image import in civil 3D, and last one is horizontal alignment. See, different part has a different work. If we, I'm going fast for each of that image. The first one, Google Earth view. This is the real world view from the Google Earth. Here we identify road and terrain condition in the first image. Okay, in this here. Then second is the third one is a global mapper. This show elevation using colors. Global mapper. This show elevation using colors. So here you can see high elevation in a red color, lower elevation in a blue color. Then civil 3D surface. Civil 3D we are thin surface and triangle. There is a triangular, you can see. So the triangles represent the thin surface, TIN, and line represent the contours. Then geolocation check. Here we verify whether our imported data matches the real world location or not. So left side view is from Google Earth and the right side view is from Civil 3D. The fifth number of image. Then in the number 6, image imported in Civil 3D. So here we import image from the Google Earth into the Civil 3D. And then we scale them and align them, which matches the visual exactly same as per the real world data. The last one is a horizontal alignment, which is maybe the end of this session and the starting of the new session. So as we all know that this is the top view of the road alignment. You can see 3 points PI, PC and PT over there. So what is PI? PI is intersection point, PC is starting of curve and PT is end of the curve. So this define the road geometry. Actually, road is not a straight or a curve like things. Actually, engineering made it smooth. So now you understand the complete journey, how we using this all the softwares. Now we are going on the next slide. So before starting this session, this is the basic things you have to understand that what is this software and what is the use of that software, why we are going to use that software. That's why I'm explaining this slide to you. This is the last slide. I'm going deeper, and then after uh, we go for a software. So let's understood these contours in the simplest way possible. See, imagine you are looking at a hill from the top. So contours are just lines that show how the height of the land changes. Here in this image, you can see different things. Mark my word and look in the image. The first one is contour lines. So this is the you can see if one contour line is 100 meter, the entire line is at 100 meter height. So that is contour lines. Then contour interval. This is the vertical difference between two contour lines. Example, if one line is 100 meter and the next is 110 meter, the interval between this contour is 10 meter. So for remember, think of it like step in a staircase. Each step has a equal height. Then you see the summit. This is the highest point of the terrain. See middle of the image, summit, the highest point of the terrain, and closed circles with increasing values shows a hill. Example, you can see 90, 100, 110, 120, this type of points in image. So the center is the highest point, which is known as a summit. Then we go for valley. You see valley at your right side bottom. So this is the lowest area. As a summit is a highest area, valley is a lowest area. So contour made in a valley in a V shape. So for remembering this, you understand that water always flow through the valleys. There is a ridge line. This is the opposite of valley. Steep versus gentle slope are there. Steep slope is the contour line which is very closely, and gentle slope is a contour line are far apart. Then elevation labels was here like 90, 100, 120. This is elevation labels. Then depressions is there. Depression is a closed low area. It is shown with special inward marks like a pit or a hole in the ground. And, distance between the line. So two important things about the contour: lines close together and line far apart. You have to remember these two things. If lines close together, then it is a steep slope, and if lines far apart, then it is a gentle slope. In a simple word, contour are a way to convert 3D land into 2D lines. Once again, I am telling that contours are a way to convert 3D land into 2D lines. And by reading this line, we can understand the entire terrain. I hope now you understand this. Okay, so step number one from Google Earth. Okay, let's we go on a Google Earth application. See, this is the main interface of Google Earth. Google Earth is very easy to install. From internet, you can download it. Or if you require the softwares, or if you require any help to download or install the software, you can contact the team Castillo. Now, you see here the white line horizontally and vertically. So, what is this? This is the grid line. Actually, grid line is helping us to divide all the word in a smaller part, to identify each part and connect all that parts and make one earth. Okay, so in a view tab, you can see here a grid bar. If you unclick this grid, the grid turn off, and if you click on a grid, then the grid show on. You can use Control L for the same task. So this is the first step. You have to start the grid for a smoothing of work. Then you have to go in a file section. See, the same command as we use in a every file in this bar. File, this is the open. You can open any file, you can save any file, you can email the file. Okay, if you have a link, you can see the link directly here. You can import the file, you can print the file. Then in edit, you can copy the location, you can paste the location. Right now we are in a beginning stage, so every part is disabled, but as we insert all the data, all the part are visible. Then in a view part, there is some important parts like toolbar, sidebar. So this toolbar, sidebar. So actually what happened, view bar is directly control these commands. So if we turn on, turn off anything, it will impact here. Then in a tool space, we have to go in a options menu. So what is the important thing? Before starting session, I talked about the different time zone. As we start our lecture on 8 p.m. in our Indian, as per Indian time zone. If you are from the different region or a different country, you have your own time zone. So every time zone have some 2, 3, 4, 6 hour of difference. So we have to select the universal time zone. Manage all our data, to manage all our terrain surface in a proper way. Okay, so what we do, we open this pop-up and select this latitude longitude tab, and here we have to select this universal transverse Mercator. In short, I called throughout the lecture it as a UTM. So you have to remember the full form of UTM, universal transverse Mercator. So what is UTM is doing? UTM is universal time zone for any of the time zone. Then after you can divide your time zone by putting your value, your zone value in it. Okay, so now apply and okay. So now I am working in a UTM zone. What we do today, first of all, as we have a less time, and have lots of things to do. So today I'm strict on a one concept, that today what we do, today we find one area, okay, then we decide one road, like this is the existing road, and we have to develop this existing road, and we import that existing road into the Civil 3D software. Also we need the terrain area, surface area of that road. So again we export that surface area in Civil 3D. So you watch lots of video, there is a lots of video on YouTube as well, Udemy as well, lots of platform are there. But today whatever we are going to see, it is a real design work. If you are new in the field, if you are a graduate engineer, if you already practice the softwares, maybe you go through it, maybe you are not, so concentrate in it and practice this session. Okay, maybe in a next week or whatever the time decided by Castillo, we are go for another one lecture. We talk about the further process. So what happened whenever after a selection of DPR, detailed project report, like that we have to develop this existing road, we have to widening this existing road, or there is a one a plain terrain, plain surface, and we have to develop this area, we will have to make a new road here. This is the two things before the starting of any work. So now we are, if there is a plain area, it is very simple. At last I will show you how to take a plain area and import it. Right now we are talking about what if we have some road and we have to take that road, and we are going to work on that road. So what we do, first of all we find one location here. So before starting this, I just again want to ask, am I audible to everyone, and am I visible to everyone?
Yes. Yeah.
Okay, I hope you understand the session and enjoy this session. Okay, so let's search with a city name, like I am from Gujarat, India. So let's start with my hometown. I'm from Himmatnagar, Gujarat, India. So in a search bar, you have to write down your city name with your district or state, search, and you have to click on the search. So what happened? You see what a beautiful view is. Google Earth take you the location at my area, what I type here in a search bar. Now you all have a mouse in your hand, so every software has a different interface to use. So this is the, with your mouse, right click and left click and a rotational click in center. So with the help of the left click, what you can do, you can up and down, right, left, the exact image. With the help of the right click, what you do, you can zoom in, zoom out. Okay, and with the middle button, you can see the view as Earth is. So let's focus on what we want to do. Okay, let's zoom in. Okay, so this is my city area. Okay, let's what we do. Let's decide one area here. So see, here is a navigation bar. The north N, the symbol N represent. We have to click N so our image becomes straight. So we can click on the button N in a navigation bar. So we can straight our image. Then with the help of this button, you can make a top view of this. and again I press N. So exactly I can see the area, whatever I want. Okay, now the real work start. See, I have a road, you can see here, a rotary intersection. One road coming, a second road, a third road, and the main road have one intersecting road. Okay, now what we do today? Today we work on a one road, so you understand properly. See, now you first of all you have to set the area. Like I set this area. I am going to work here. Okay, here in below you can see the date. So today is the date. I am 29/3/2025. So this is the satellite image date. Okay, then here you see 43Q. I hope it is visible, or and if it is not visible, you can open the Google Earth in your computer or laptop. You can see the coordinate here, the easting, northing, and elevation. So elevation is 165 meter. I alternate distance is 588 meter. So all the things you saw here, wherever you click your take your cursor, all the detail change as per the exact coordinate location. So now first of all, what I have to do, I want to take this road center line, this one and this one in a L shape, and then I want to take this surface and this surface, this both surface. So let's start our work. So here we have the first of all we have the place mark. So place mark has a use itself, but today we are not explore this place mark. Then we have a polygon. So if we want to directly take a contour from the plain terrain, we can use this polygon option. It is also useful. Then add part option. So today we start the add part option. So you have to click on a add part. Pop-up is open. Now we give the name. Okay, the first of all we give the name like road center line. Done. Then you can fix the different style whatever you want. Like if I want a red color, then you can choose red. You can minimize maximize the width. Okay, you can uh, view all the details. If I click if I click here, then if I take all the points, so it per the you can check all the heading range, you can add this. You can check all the altitude in all the things. Whatever the road distance, you can decide here in kilometer exactly. What is the real design industry workflow? Like if we take a unit in a kilometer, and if we decide that every 500 meter we are taking a center line point, then we have to take that every 500 meter. Like our first point is there, if second point is there, third point is, so this is a 1 kilometer. Then if we decide our all point is on at 1 kilometer distance, then the another 1 kilometer. See, this is not one, this is 2 kilometer. So this is the process. But right now we are just taking the point to understand the workflow properly. So what I do, I am taking all the points from here. Let's start from here. Okay, done. So I am taking all the center points. You can zoom in, zoom out for help. Okay, again, if you want to denote something like there is a tree here, you can denote it here. See, I try to maintain the perfect center point. See, while you are working, while you are clicking, just concentrate on the points that you click. Okay. See, okay, if this is we take 0.46, we take 1 point here, done, done. Okay, now we click on a OK button. So we have this one mark name as a road center line. Okay, so now what we do, we save this road center line. Let's here save places. Now remember, whatever the file we save from the Google Earth, it is in a KMZ format. So file name is road center line, and I am save this in our today's lecture as a name of road center line. Save, done. Now the second thing, we have to take a OGL level, original ground level. So for that again I am taking this path and saying that this is OGL. If you want a different color, you can take a different color from here. Okay. So don't click OK button without completing your task. If you click OK button before completing your task, the command is cloned. So remember the one thing. So here what we do, we take surface point from here. So you have to click all that point like this. So for saving the time, I am taking point in a speed. The more point you take, the more accuracy you will get here. So don't worry about where your point go. They are just checking that wherever your point is clicked, almost that point OGL Google Earth put. Okay, done. So now I'm saving okay. Now again I am save this OGL as a KMZ file. Save, done. So we do two things here. First of all, we take a road center line, and then we take a ground level.
Look, your screen is not visible. I think connection problem. Please check again.
Okay, give me a second.
It's visible. Okay, you can start.
Okay, so here we take two things, road center line and OGL surface. Now, see, Google Earth give us two things. They are not providing us a exact elevation. So if we want a exact elevation part from for this terrain, so for that we are going to use the global mapper software. So now let's start the global mapper software. So this is the main interface of the global mapper software. So in a initial part, what we have to do, the same as we did in a Google Earth, we have to go in a configure setting, and in a projection tab, you have to set here UTM as we start our work as a UTM. Done. UTM. So our projection is now UTM here in Google Earth as well here Global Mapper 2. Okay. Now as we import our road center line and import our surface, OZL surface, then what we do, we the zone here, and we if there is a difference, we can change here the zone, so we can get a exactly point where we work. Okay, apply and okay. So now let's open the data file. See, first of all, we take a road center line. We have to click the road center line and open it. So it will take some time. After clicking your road point here, road center line here, what you have to do, you have to connect this data to the online. Okay, so select this data to the online part. So there is a various source of data here which is connected with the satellite tools. So many companies or so many peoples are using Ester resolution, but I'm personally using SRTM elevation data. It is give a good result. So we have to connect it as with the internet. It will take a little time. Okay, till let's start our Civil 3D software. Open a new file. Okay, so this is the interface of our Civil 3D software. So first of all, when you start your Civil 3D, you have to set some points, like in a setting, there is you have to manage all the things from here. So this palette is known as a tool space. You can manage this tool space from here also. You can start, you can end the tool space from here too. Okay. Now when you go here in your setting bar and you see here drawing number 1, you can right click here and go in a edit drawing setting. So in edit drawing setting, you have to set all your units, like drawing unit is in a meter, imperial to metric conversion, scale, then the zone. See the zone here. So we have to set the zone as a UTM here, UTM, and then whatever the zone we have here, like we have here in a Google Earth, zone 43. See, in a Google Earth, we have the zone 43. So what we do, we put here, what you have to do, you have to just change here 43. Okay. As you change this 43, your Civil 3D location set as per the actual zone where you worked on. Okay. Now it is worked properly or not, how to check? As you set your unit, you can see here geolocation. See, geolocation, if geolocation is on, then understand that your unit zone you set here is all good. Okay, now look at here in Civil 3D. I think there is one problem. Don't worry, let's start again the global mapper. It's happened sometime. It is a software, it will take time. Okay, see, this is our first interface. So what we do, we open the data file. So first of all, we have the road center line. We open that file. Okay, now it's okay, perfect. See, the road center line, which we located in Google Earth, exactly the same center line you can see here, right? Now what we do, again we go projection. We set projection is UTM. Okay, now the projection is set. Now what we do, we connect it with the internet with our satellite. Okay, as if you are selecting this ester view, it is well and good, no problem in that, but I prefer SRTM for elevation. So next, and then connect it to the internet. So see, now the global mapper perfectly give all the data as per the extracted as per the Google Earth data. Okay, now what we do, we export this file in a vector lidar format. Done. From vector lidar format, we have to select, you can see here, simple XYZ, simple ASCII XYZ text file. So why we are taking a text file? Because we have to create the surface over there. We have to create the road center line over there in Civil 3D. And to create a surface and center line, we need a point set. What is a point set? I will explain you after this. So we take this simple text file. See, there is a different type of file here. You can export the file as a PDF, DXF, DWG. Lots of format are there. But for remember the one thing, that if you want to import the point, elevation point, you have to export this as a XYZ simple SCI text file format. Okay. Okay. Now coordinate separator, you have to select as a comma. Feature separator as a blank line. Coordinate order format as a X longitude. Either rest of the thing is okay. 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 Now file name. So this is our road center line. Again, we type that road center line, and this is in a text format. Okay, save. Done. So we did one thing. We export our road center line point in a TXT format. Now what we do, we import our OGL data here. So we don't have to start again from the starting. What you do here in control center, you have to click on the road center line. Okay, and close the layer from here. Okay, yes. So your road center line is gone. Now we open the file OGL. Open. See, your OGL file is here. Okay, all the point is set here. Again, I am exporting this file, vector lidar format, XYZ file, text file format. Okay, all the system is set. Okay, now the file name is as OGL. Good. Okay, done. So let's go to our folder. So here, what we have, see, we have one KMZ file, OGL in a KMZ format, which is exported from the Google Earth. Then we have a OGL file, which is in a text format, exported from the global mapper. Then for a center line, we have the same file for the center line. Okay, let's open the one file. Okay, what we do? We have to start one Excel file. In Excel file, we say the file name is a survey data or whatever you like. You have to open one Excel file. Now what we do? Let's start with the road center line point. So if you open the text file, you can see all the points like this: elevation, northing, easting. So there is a one format in a Civil 3D. See, I will show you. If you importing the point from here, point creation tool, and let's see, there is a different point format here: PENZ comma delimited, PENZD space delimited, PENZD comma delimited. So we have a different file type. So we have to make our CSV file in this format. And when we import the points here, we have to select the same point format which we created. Okay. So what is this PENZD? P is for point. Point means 1, 2, 3, 4, 5. Right now we are creating this file format. So don't worry, you understand the things. E is easting, N is northing, is elevation, and D is description. Description, like if there is a point near the tree, then in description they are mentioning the tree here or any obstructs here, that type. If a center line point, then they are maintaining all that description over there. Okay, so I hope you understand this point format. Why I'm showing you? Because we are going to create this. See, we have the point from here, starting from here. We go at the end, shift and click here. We select all the point. We copy this point, open the Excel file. Okay, paste this point here. Okay, see, now all the points are one row. So first of all, we have to extract all these points. See, we have a 1, 2, and 3 point in a one row. What we do, we have to go here in a data. Then we go text to column. So exactly, this is the process. We converted the three different point in a three different column. So here we have to choose the delimited as the comma or tab separated each field. So we have to separate each field. So for that we have to choose this delimited. Then we select the next button. Then we use delimiter as a tab and comma. Okay, see, done. Then we go for a next. Then we'll done. Okay, then you can see text here. You can see this. See, now we have a 1, 2, and 3. Easting, northing, and elevation. 3 points. Okay. Let's start 1.1, 2, 3. So this is the P in a format of P, E, N, Z. And for the description, here we have a center line number 1, center line number 2. So, okay, done. See, this is our P, E, N, Z, D format. So we do this for our road center line. Now we do the same thing for our OGL. Okay, let's go in our folder. Let's go for the OGL. Let's select the OGL point from here. Okay, Control C. Go go here. Let's put it here. Control V. See, uh, once you performed the art of make it from text to column, we separated all the text in each column, so the task is repetitive. So in second time we don't have to do it again. See, all the points are in a different column. Now we give a description as a OGL, original ground level, point number 1, OGL point number 2. So done. So we extracted this much of points here, 31, 32. Then we go again. The total we have 107 points. See, now what we do, we save this file. We save this file not in a Excel, but CSV comma delimited format. So the most and important thing in a civil 3D or in a work of highway or infrastructure design work, you must have to understand, you must have to remember the file format, because this only the file format is that which is help you to make your work smoothly. Okay, let's come here. Let's insert the points. So we have whenever you start your work, you have to set your file. If you say, if you go in a file and save as the file. Okay, let's save this file here in our folder. Uh, Practice lecture surface and road, done. So first of all, you have to save your file, and then in a setting bar, you have to set your setting UTM. See, I set my time zone 43N as per my area. Here, my area is 43Q. So I set this in a civil 3D as well. Done. Now my unit is set. Now I have points over there. All work is finished. Now the next work is to import this point. So there is in civil 3D, all the work has a 2-3 way to do the same work. When you are doing the work, or whenever you are working on the civil 3D, whatever the simplest way, whatever the easiest way you find, you have to stuck on a same thing to make it proficient. Okay, everyone has their own style, so don't change your style again and again and again. If you are practicing from the YouTube, even he or she taken any other step, but if you are importing the point and if you know one style, then you must have to consider one thing only. Okay, I see here in a chat box there is a lots of question here, so don't worry. You can ask the question after the session on WhatsApp channel. On we have Shivam sir in a Castillo over there, or LinkedIn. You can ask anytime, anywhere. So don't worry about your questions. We solve all your queries. Just focus on the workflow, because this is the things, whenever you go for the interview for a first time, uh, this is the thing you have to know, because whenever you go for the job, in a real life is very hard here, because your colleague, all colleague is not good. They are not going to teach you all the things in details. So that's why they are saying teachers is like a mother. So mother is, saying all the things in detail, even though you are not understanding. So just focus on the workflow. Don't worry if you don't understand, just practice. If you don't get anything, ask me. I will be there always for you. Ask our Castillo team. And you can also join the Castillo if you want to advance your level in all the things. If you want to do some real life project, we are implementing 7 kilometer of 9 kilometer of road intersections, real life design project. If you want to do, you can join the Castellio too. You can contact the sir. All the numbers are in WhatsApp groups. So now what we do, let's come to the point. What we do, we are going here in a point. So this is the first method, point creation tool in a points. See, this is the interface of Civil 3D. It is the same like AutoCAD, because AutoCAD and Civil 3D is both a child of one mother, Autodesk. Okay, so interface is same. A little thing is different. 100%, a little thing is different because of the workflow. Here you can see in workspace, you can see the drafting and annotate. If you click here, you can go in AutoCAD 2D. 3D modeling you can do here, planning and analysis you can do here. So right now we are in a Civil 3D, so we focus on that bar. We have a different type of ribbon here. Each ribbon has their own use. So we are not going to explore all in details, but we are taking that the ground, create a ground data. See here, this ribbon, and the another thing here, the palette bar, the tool space. This two is very basic. So whatever the work you are doing in a Civil 3D, either it is from the infrastructure field, either it is from the railway field, either it is from the utilities field, whatever field, you have to use these panels. Okay, so if you are master in this tool space, 30-40% work almost done here. So we do all the work from this prospector tab. If you want to do any setting in a particular, like there is a point, and if you want to do some setting in the point, so you come here in a setting bar and you can do all the setting, you can manage all the setting from here. There is a one survey tab. Lots of people, they are not even though they are using the Civil 3D, they are not knowing that why the survey is used for. Survey is used for, because in a Civil 3D, in a road project, there is a very big infrastructure project over there, and the file size is very heavy. If you are working in the same file all the things, then even your computer is more and more advanced, it will stuck. So to not stuck while working, we use this survey toolbar as well. Here we have data shortcuts. See, in a prospector we have data shortcuts. Data shortcuts is also helpful to save our project memory. So what exactly data shortcut do? It divided whole project in different parts like points, surface, alignment, then profile, corridor, assemblies, and each folder has contain each work only. So if you are working with beam coordination, if you are working with a team, there is a different person for a different work. For alignment creation or for profile creation, there is a different person. For planning, there is a different person. For designing a seat, there is a different person. And for observation, there is a different person. So what they do, they are managing their work in their own folder, and they send them through these data shortcuts. There is a lots of the cloud is there, beam is there. So all the work merge at one place, and the observer observe all the work that today this work happened from this place. So this is a beauty of this Civil 3D. So this is the work of survey, work of data shortcut, then the work of settings in a prospector. So before starting the Civil 3D, you have to go with the flow. Like first of all, we want to import the point, then we have to create the surface. If we have a surface, then on that surface we have to create the alignment. After we have a horizontal alignment, we have to view that horizontal alignment in a vertical profile. So once you have a vertical profile, you can create your design profile. You have your vertical and design profile. Based on that, you can create your assembly. If you once you have assembly is what? It is a cross section of road basically. Once you have your assembly, then you can make your corridor, assign that assembly in that corridor, and once you have your full corridor in a working condition, Then after you can view that corridor in a different section view. Okay, then you can calculate your quantities, calculate your materials, and you can create your design sheet and send that all sheet to the client. Also you can export all the result in Excel files or web files. There is no plus icon in starting of this point. It means there is no work here. Okay, so now we right click here, we create the point. So we have this pop-up bar, create points. This is the step number 1. Now step number 2, we are going here, point, from point creation tool, again the same pop-up. See, is one more thing, but the lengthy things, don't consider all the things. Choose the easiest way to import the points. I feel this is the easiest way. Create the point, import this point. Okay, so now this is the important pop-up. What we do, we click on this green button. Okay, now we have the survey file in a desktop. We go in our folder. Okay, we go in a survey data. Make sure we have two files. One is a Excel and second one is a CSV. So we open that file. As we open this file, see what no point file format match found. See, so the most important thing is whenever you import your point file, you have to make sure that your point is clearly mentioned here as a right click. So it is not, it means you have some issues over there. You have some issues over there. To solve the issue, what you have to do? You have to check all the things again and again. But this is not a very big task. A normal things like see, in a survey file, again we import the points, create our points. See, we have lots of point here like projects, survey data in a PENZ format. So now we importing that point here, and we see here the click mark, green click mark. Okay, so it means that the point we are selecting, it is right now in a good and well formatted. Okay, then what is our file name? PENZD. So we have to find here PENZD comma delimited format. Okay, as we click here in this format, you can see here in a view bar, in a point number there is a point, in a string there is a string, in a northing there is northing, in a point elevation there is a point elevation, and in a row description there is row description. If you want to create a group here, you can create a group here too. Okay, so now you can see before here there is nothing to show in front of your point, but now after importing the point there is one mark, and as you click here in a point, you can see your own point here in a below tab. Okay, now what is the procedure to show that point is perfectly, your point is perfectly imported. Now I want to see how my point is look like. So for that there is a one command that z enter e enter, z enter e enter. See, so whatever the line we selected, see all the points is here. So this point is known as a cocoa point. See, the name is a cocoa point. Now the next step I am explaining that the point, the most important thing is point group. So here we have all points because we imported all the points here. In a point group, we have to create a new group. Okay, here we can change the name, like if we have a road center line, what we do, we go here, row description matching. See, first of all, I will show you the properties of these points. Okay, let's select the point. Okay, so whenever you select the point, here you can see in this bar, point group properties. So I select a single point, that's why it's saying the point property and point group property. Okay, I can select all the similar. We can go here in a point property. See here, so here is a point style. So here is a basic style. I can choose any of this style. Okay, and then point label. So I can put any, like if I want elevation and description, I can choose this and apply. Okay, see, so all the elevation and description over there. I choose design as a benchmark, so I can see the benchmark over there. Again, I am going here. Let's do a basic, then we go for the point number only. Apply. See, only the point number is there. If we go for the northing and easting, all the northing and easting is there. Okay, you can scale it down for good visibility. Now the second and important point, so this is the last thing we are going to see today. So we have three things here in a point. We have the center line, we have the road surface, and we have all the points. So we can create the group from here, point group, new group. So we have to remember the name, whatever the name we give here, CL1, CL2, and all that names. So what we do here, we go here in a exclude bar. So they give us a different options, like with the row descriptioning, like we put a CL, then we have to here CL and star. Okay, if you click here and write down the description name, so whatever the point name CL, that make a one group. If this option is not suitable for you, you can choose with elevation matching, you can choose with the description matching, you can choose with number. If you put the number here, they extract the number. Whatever the number you selected here, all are shown here in a point list. Okay, now the next and important thing is surface. So first of all, what we do, we are going to create a new surface. So in surface, whatever the name you can give, you can give the name like basic surface. So in a description bar, there is a style. This is the contour style. Okay. So now the surface is created, basic surface. We have to click in a plus icon. We have to go in a definition. Again, click on a plus icon. Then we go in a point group. As we have a point group, we can go and right click on a point group and add that point group. Now what we do, we create a surface box at one place. We have point group at one place. Now what we do, we have to put that all point group in a surface box. So what we are doing, we are putting this all point group in a surface box. See, now this surface is created, whatever the point we select. Now you can check the property of the surface too. So in any option, in any command you choose, like if you create a surface and you select the surface, then you have this property and surface style, properties bar and style bar. Properties or surface style. So in a surface, we go in a surface property. So you can see here basic surface name and all the things. As we point, what we do, we change all the background and all the things, like we choose any elevation. In surface 2, we can choose all the things, like if I want to see contour and triangle, see contour and triangle in a surface. If I want to see it as a slope bending, see what is the different color, why only this color. So this have here analytics tool, so you can change the range of the color from here. Okay, you can give the ratio here, like from this elevation to this elevation it is called a red contour, red color, and it is not good. So this type you can define here in this analyze bar. In a statistics bar you can manage your contour, like what is the number of triangle here, what is the total area, and all the things. In a definition bar, so whatever the work you perform, it is shown here in a definition bar as point by point. Like this is we do a first point, then if we are creating any new things, it is coming below it. So see, triangle. Okay, okay. Now, like if we take one road like this, okay, so this area is not coming under our study. So what we can do, we can edit this surface by delete line. So we can simply click this and enter this, click and enter, click and enter. See, so the exact the line whatever we select, we can check here our road and enter line. I hope you all are understand. Now, in the next topic, what we do, we are going to, we are going to design a full road project with. We are check all the surface. Where is the slope of the surface? How to check the surface slope? How to create the alignment? While creating the alignment, what is the observation we have to take care? While creating the horizontal alignment, what is the radius, what is the tangent, why we have to put only this radius, what is the minimum tangent length required, what is the equation to calculate that radius and tangent length. So this is the work of a real engineer, and you have to understand all that workflow. Because civil 3D is just a tool. As you practice, you understand the flow. As you practice, you become an expert. But engineering is not like that. In engineering you have to calculate all the things, you have to understand all the things, you have to implement all the things. Because every time in each new project wherever you work, there are some different conditions. If you are working in an office, if you are working in a school, if you are working at some place, every day is same. Like you have to doing the same thing. You have to sell the product, customer is coming, you have to manage the finance and all the things. But here in engineering, all the day different, every day new challenges. So you have to update again and again, again and again, again and again in all the aspect. See, in civil 3D there is two more important option to understand. The first one is geolocation, as we explore. The second one is here sub-assembly composer, civil 3D sub-assembly composer. When we check the sub-assembly, when we create the assembly in a civil 3D, so this is the sub-assembly composer. You are working in any design company, if you want to modify the retaining wall, if you want to modify the ditch, if you want to modify the canal, or if you want to modify the road section, so indirectly civil 3D it is a little tough work, but you can manage that here. So this is the sub-assembly composer. This is also one thing you have to know. And the second thing is dynamo. So here in a express tool, see, then we have a infra work. So infra work is what? Infra work is what we do, we take the Google Earth data and put it here. what infrawork do, infrawork give you 3D models. So all the things we see here in a 3D lines, in infrawork we see all the things in a 3D view. Okay. And the last thing is I want to tell you that is dynamo. So dynamo is one thing. Dynamo is basically what dynamo is uh, expert things given by the civil 3D. You can find here in a manage tab. It is a dynamo player. For using this dynamo, you have to understand the basic Python work. But it is when once you take a mastery in the highway design software. So this is it for today. As time is also gone so far, 9:14 is there. I will sure try in a next session. I will give you I will provide you some real life example by creating the alignment profile, corridor, intersection, assemblies, and all that things. I hope you all enjoying this session. So once again, my name is Dr. Abrar Khalak. My motto is sharing is caring. I request all of you who is attending here always help each other as we are engineering community. Always help each other even if you get benefit or not. Help each other. So that's it from my side. Our sir from the Castillo Design, they are giving you the feedback form. Kindly please fill the feedback form. And again, if you have any question or if you have any query, you can contact sir, contact me, contact through WhatsApp, contact through LinkedIn. We are always open there. And if you need any type of support, you can contact us. We are always here for you. Thank you so much. Here I'm ending the session. Respected sir. So participant can leave the session.